If you have ever wondered why an anti-detect browser can look flawless on screen and still get flagged in the first 10 minutes, the answer is not in anything you can see, it is sitting in the JavaScript runtime underneath the page in scenes a detection script will find that a human eye never will. I run proxy infrastructure and cloud phones for a living, so multi-accounting is part of that world whether anyone likes it or not. I have put more anti-detect browsers through real, hands-on tests than I can count. From the well-known names everyone recognizes down to obscure forks nobody has heard of. And I have watched the differences between them show up in ways that have nothing to do with how nice the interface looks or how confident the pricing page sounds. Most of what separates a serious tool from a weekend project only ever shows up once you go digging into the runtime itself. Before I get into any of this, I want to be clear about what it is and what it is not. This is not a guide to beating any platform's detection or getting around anyone's terms of service, and it is not a how-to for anything like that. It is an explanation of the mechanics, because understanding how JavaScript runtime detection actually works is the only way to judge whether a given browser's spoofing is thorough or just cosmetic. Every anti-detect browser I have tested does the same basic thing under the hood. It patches the JavaScript runtime so a page sees a different navigator, screen, and hardware profile than the machine actually has. That part is the easy half of the job, and pretty much every tool on the market manages it. The hard half is that patching a runtime and actually replacing it are two completely different engineering problems, and most tools only ever do the first one, which is exactly where detection scripts go looking. A browser fingerprint is not one signal, it is dozens of JavaScript properties and API responses stacked on top of each other. The user agent string, screen dimensions, the WebGL renderer string, time zone data, font metrics, audio processing output, and plenty more besides. Overriding these so a script sees Windows instead of whatever the host machine actually runs is straightforward, and every serious tool clears that bar without much trouble. What trips tools up is that JavaScript engines expose metadata about their own functions and objects, not just the values those functions hand back when you call them. A detection script does not just read how many CPU cores you claim to have, it inspects how that property is actually implemented underneath. If the implementation looks different from a stock browser, that difference is a signal all on its own, completely separate from whether the number itself looks believable or plausible for the device you are claiming to be. Here is a concrete one, and it is probably the single most common tell out there. Every built-in browser function, when you ask it to print its own source code back to you, returns something short that basically just means native code, not any real JavaScript you could read. That is simply how the engine represents a function that is compiled rather than written in script. When a tool overrides a property with a plain JavaScript getter, which is how most spoofing actually works under the hood, the naive version of that override leaks its own source code instead of showing native code the way the real thing would. Detection scripts have been checking exactly this for years now, asking a function to describe its own source the moment a property looks even slightly suspicious. A tool that overrides a value but forgets to also patch what that override reports about itself leaves a dead giveaway sitting right there in plain sight. A property that claims to be native while happily handing over the exact JavaScript that is faking it underneath. The fix for this is well known among the serious vendors at this point, and it is not particularly hard in isolation. But it has to be applied consistently across every single overridden property on the page, not just the obvious handful, and that consistency is exactly where the cheaper or less maintained implementations fall apart under any real scrutiny. A lot of modern spoofing does not hard-code values with a simple property override anymore. It uses JavaScript's proxy objects to intercept property access dynamically instead. Proxies are flexible, which is why they are popular, but they change how an object behaves the moment something inspects it rather than just reads a value of it. Pulling a property's descriptor or listing out every key on a proxied navigator object, or checking what sits above it in the prototype chain, can all return a shape that is subtly different from what a real, untouched navigator object returns in a normal browser. None of that is visible to you sitting there looking at the page render normally. It only shows up to a script that was written specifically to probe an object's internals instead of just reading the surface values a human would care about. That is really the core reason why a profile looking right while you are using it tells you almost nothing about whether the runtime underneath is actually well spoofed or just good enough to fool a glance. There is also a whole category of check most people never think about, and that is timing. Spoofing a timesines means overriding the timesine functions JavaScript exposes to a page. But frame timing and the browser's own performance timers are driven by the actual host clock and the actual GPU compositor doing real work, not by anything a script can override the same clean way it overrides a string. A detection script can compare the time zone you are claiming against how frame timing subtly drifts relative to that clock, or check whether the timers on the page line up with each other the way they would on a real, undisturbed machine. These are second-order checks, and not every site bothers running them, most don't, but they exist precisely because the obvious stuff, the time zone string, the locale string, is the easiest thing for any anti-detect browser to get right, so anyone building serious detection tooling has already moved well past checking that directly and started looking at what is harder to fake. Modern Chromium sends a whole second set of browser identity signals alongside the classic user agent string generated by the actual engine build itself rather than something you can just set with a line of code. If a browser patches the user agent to claim a different Chrome version or a different operating system, but does not also align those other signals and the actual headers going out with the network request, a script checking both sees two different browsers claiming to be the exact same sessions, which is about as clean a tell as it gets. This is one of the more common gaps I have personally run into testing tools that were clearly built before that second identity signal set became standard practice and never got fully retrofitted to keep up with it. It is not exotic or obscure, it is just maintenance debt showing up as a fingerprint mismatch that a script can catch in milliseconds. A separate category of tell has nothing to do with fingerprint spoofing at all. It comes out of automation itself. An automated Chromium session sets a flag saying exactly that by default out of the box. Older automation stacks leave behind leftover variables from tools like Chrome Driver or trigger detectable behavior the instant certain DevTools protocol commands get called during setup before a single page even loads. There is a smaller, related mismatch worth knowing about too. A browser's notification permission state is supposed to agree with itself no matter which API you ask through. Some spoofing setups patch one of those and quietly forget the other, and that is a small inconsistency, but it is a checkable one, and detection scripts check exactly the kind of thing that is cheap to check and easy for a vendor to overlook. Tools built on a modified Chromium and driven through that automation protocol have to specifically strip all of these markers out, every time. It is a solved problem for the major vendors who take it seriously, but it is also exactly the kind of thing that quietly breaks again after a Chromium version update if a vendor is not rigorously retesting every single release against known public detection scripts before shipping it to customers. Hardware claims can contradict each other too. WebGL exposes a vendor and renderer string that is supposed to reflect the actual GPU sitting in the machine, and device memory and CPU core count are supposed to reflect real specs as well within the rough buckets browsers already round them to for privacy reasons. A profile claiming to be a mid-range phone while reporting a desktop GPU renderer string, or claiming 4 gigs of memory sitting next to a 16-core processor, is internally inconsistent in a way any script checking more than one property at once will catch almost instantly. No clever detection required. That kind of thing is less about clever detection code and more about the profile itself being poorly built in the first place, which I run into a lot more often in cheaper or less actively maintained tools than in the ones that get regular, ongoing engineering attention from a team that actually tests against real detection scripts. So what does all this actually mean if you are the one sitting there evaluating tools? None of it makes any anti-detect browser undetectable, and nothing here is a promise that a given tool will keep any account from getting banned, because that is simply not something anyone can honestly promise you, and you should be skeptical of anyone who does. What it gives you instead is a real checklist for where to actually look past whatever the sales page tells you. Does it patch that source code check consistently across every overridden property? Does it keep the newer identity signals aligned with the user agent? Does it keep hardware properties consistent with each other instead of quietly contradicting themselves? And does it get retested against new browser releases instead of getting built once and left alone to slowly rot as Chromium moves on without it? Conference in DC Titstan. Buiti. Names like multilogin, gologin, Camleo, AdsPower, and Dolphin NT all take genuinely different engineering approaches to these layers, and the differences between them show up in exactly the checks I just walked through, not in how smooth or polished the browser feels while you are clicking around inside it day to day. If there is one habit worth building out of everything I just covered, it is testing a profile against a public fingerprinting or bot detection demo before you ever rely on it for anything that actually matters to you. That 15 minutes of poking at it yourself will tell you more honestly than any vendor's marketing page ever will, no matter how confident that page sounds or how many logos it puts in front of you. I test these browsers on real multi-account setups, so the written reviews and the picks I actually trust are all at antidetectbrowser.org. Full written reviews and the tested picks I actually trust are waiting for you at antidetectbrowser.org. So go take a look and subscribe if you want more breakdowns like this one.